Now they can do a couple of things. Number one, they can ask you simply what's x. And if you are paying attention to what I gave you a while ago, you should know what x is. What did I tell you in one of those four things that I just wrote out? Huh? What did I tell you about the sides? They're parallel, we know that, but they're also congruent or equal. So I know if I want to find x, I know that this side is equal to this side. So if one side is 7, then the other side is automatically 7.
So x is 7.
So it's just x equals 7 because I know my rules. Since they are equal, they are opposites, then I know that they have to be exactly the same. What? Are you having some problems?
Yes.
Well, come get another one and let's don't make a mess this time.
So if x is moving at the top part and 7 stays in the same side, like
You can't do anything with that because they have to be on the same side. So it's either both top and bottom or both on the side. Can't have one on each. Okay? So the question, listen, the question was asked, what if x was on the top and 7 stayed on the side? You can't do that. Because they either have to both be on the side or both be on top and bottom. You can't compare a top to a side. Because we don't have any rules for that. Now, also, I could tell you that this angle right here is 18 degrees, and I can ask you to find this one. So if I say find the question mark, what do I know about angles?
you said that one was 180 or 80.
That's just 18. Okay, I told you if they are diagonal from each other, that they are equal. So that means these two are equal to each other.
Yep, so that's 18 and blue.
Yes. So the question mark is 18 degrees.
I said that should be 18 too.
So if I pay attention to the rules that Ms. Sullivan gave me, I can find these most of the time without actually having to do anything. Just simply by knowing what pieces are equal. Now that does not work for all of them, because sometimes you actually have to work things out. But please get the easy ones like this first one. So if they are opposite sides, they have to be the same measure. If they are opposite angles, they would have to be the same measure. Now, if I asked you what y is down here, if I asked you what y is down here, how would you find y? How would you find y, which is down here in the corner? Several of you have already talked about it. What do I know about the angles top and bottom? They're not equal. Only the angles diagonal are equal. If the two on the same side, top and bottom, you have these in your boxes. They're 180. I just gave it to you. I just told you right here. The two angles on the same side, top and bottom, have to equal 180. So how is that gonna help me?
If you know that together they're 180, how does that help you?
We've already done this numerous times for the last test.
You work
80
together.
minus 18.
There you go. If you know what it equals and you know one of them, work backwards. So all you've got to do then is 180 minus the 18, and I should know what that equals.
Teachers, excuse the interruption. Will the seniors of the TAP class Cooper, Smith, Graves, and Shields report to the library for pictures? Will the students of TAP classes Cooper, Smith, Graves, and Shields report to the library for TAP pictures?
Okay, a couple of you have your calculators. What'd you get? 162? Couple of you have yours. I think that's what you should get.
Yeah, 162.
162. So you should find out that y would be 162 degrees. So if I know one and they are top and bottom, then all I gotta do is subtract it. So we've got to learn these rules. Because I'm pretty sure you have an IXL tonight. And they're going to be asking questions like these. And some of you, you don't want to learn the rules that I give you. You expect to go on IXL and some miracle happens, and then you come back and complain because you won't learn your rules. I can't help you if you won't learn your rules. So, opposites diagonal have to be the same. Opposite sides have to be the same. Top and bottom have to add to equal 180 or subtract it from 180 to find the missing. Now, look at this one. Again, what do I know about sides? What do I know about the two sides? They are congruent, which means they are equal. So take your pencil and write down x plus 3 equals 2x plus 5. All you gotta do is write it down. This one equals this one. Oh, thank you.
I couldn't get my finger in there.
So now, all you've got to do is solve this. Now, Mr. Martinez is bringing calculators around. I didn't see any feet, but I don't mean anything. There's nobody out there, but that don't mean nothing. So, Isaiah, have you finished this one? They are telling you that it's nice when they are with numbers like this one. But they're not all going to be nice simple numbers like this one where you say, oh, well that one's 7, so this is going to be 7. Sometimes you're going to have to set them equal and actually solve. You cannot avoid having equations. That's x plus 3 and 2x plus 5. So then you've got to solve it and find out what x equals. And I will tell you x is a whole number, but it is a negative number. That is correct. But again, you have to know how to set these up. I'm not going to be sitting with you in front of IXL. Now, this is a whole number. Is that a whole number? can only go with another X.
This space.
So we got the minuses with them. Yeah. Yeah. So we'll just like that.
So 3 equals that.
Yes,
okay?
yes, that's
Now,
correct.
okay. You know the X like that.
I know.
To get rid of this.
Have you done all your homework? Have you done tonight? No, because I ain't given it to you yet. And I still have 2 other things to show you.
16.2 bit. Or let's go here.
Uh-huh.
What day is it?
What day is what?
That's a whole nother beginning.
It's on the 14th.
16?
Well, that would be this week.
Oh,
So I'm pretty sure Thanksgiving is not this week. It's still at least 2 weeks away. It's the 26th. It's 2 weeks from Thursday.
We got like another week on before we get out.
You got this week and you got next week.
And then we'll be out for the week.
Not the 14th. Yes, sir. No, remember you gotta set them equal to each other. You gotta say X plus 3 equals, because remember these 2 sides are equal, they're the same. So that's gonna be 2X plus 5. So now, you can't add them if they're on the same, on opposite sides. That's the one you gotta move. So you gotta move X's to the same side, you gotta move numbers to the same side. So that means you gotta do a lot of add and subtract. Okay. Now, let's look at this. So I've already told you that they've got to be equal. Because if one side is 10, the other side is 10. So that means this side equals this side. So that's what I did, I wrote them out that way. Now solve it. I don't care where you move your pieces. I like mine in the front. So I'm going to subtract 2x. So now, remember this is a 1. So 1 minus 2 is negative 1x plus 3 equals 5. Now I've got to move the 3 back the other way. So now instead of adding 3, I'm going to subtract 3. So negative 1x equals 2 now. So divide by negative 1 and you should get your answer. Hello? Hey. I sure do. Yes, he should be able to come down just shortly. You are welcome. Bye-bye. Huh? It is. Okay. So, when I divide, I should end up with x equals negative 2. Okay, so make sure that you know, again, it doesn't matter if they are just plain numbers or if they are pieces like this. You got to set them equal, and then you got to make sure you solve them if they've got letters. Okay? Now, that's again the same stuff I've already told you. Diagonals are equal, opposite sides are equal. If I've got 1 right angle, I've got 4, all that good stuff. You got to make sure you remember that. Now, I've got 2 more that I need to show you real quick. These are about diagonals. Now, we haven't necessarily talked about diagonals yet, so we've got to get these in. So, the first one I've got is 6.7. I'm going to do another rectangle real quick. Now, in my rectangle, I'm going to draw 2 sets of diagonals. So draw your diagonals coming from each corner. So I've got my diagonals.
Draw that with the pen.
So I've got my diagonals. So I've got my diagonals. So draw your rectangles, draw your diagonals. Now, I'm going to show you what the diagonals mean. So get it drawn. Now, in here, these diagonals bisect each other. What does it mean if they bisect? Okay, bisect means that they're going to cut each other in half. So they're going to cut each other in half into 2 equal pieces. So I'm going to put that down here in parentheses. Okay, so I said the diagonals bisect each other, which is what it does, and it cut each other in half. So that's what they do. They cut each other in half, which means they make 2 equal pieces. So, if they cut each other in half, and they make 2 equal pieces, then what that tells me is that each diagonal, each piece of the diagonal is going to be congruent to the other piece. So, I know that this piece of the diagonal is equal to this piece. Because this diagonal cut that one in half. So if this piece is 5, this piece is 5. Those 2 pieces are exactly the same. Now, it also tells me that this piece is equal to this piece. Now, do the 2 diagonals have to be the same? No. It's not what it said. It says they cut each other in half. Nowhere did it say they had to be the same. So we know that the 2 diagonals have to be cut in half. So each piece has to be equal to the other piece. So this piece has to be equal to this piece. So they're both 5, they're both 15, they're both, -2, whatever they are. Same thing with these 2. These 2 pieces have to be exactly the same. Now we've already learned that this piece is equal to this piece, and we already know that this piece is equal to this piece. So we've got a lot of equal pieces inside these parallelograms.
Yes, sir. What do I have to know?
Huh? Can you hang on a minute?
No, I was just asking.
Just hang on a minute. Let me finish my lesson and you can go. And I'll tell you where you gotta go. So, we got a lot of equal pieces in here that you need to know about. The diagonals, the top and bottom, and the sides. And the last last thing you've got to remember is in 6.8, I've also got a rectangle. This time in my rectangle, I'm only going to draw one diagonal. Only one diagonal. Don't draw both of them, just one diagonal. I don't care which way you draw it. That's up to you. But I only want one diagonal. So I only want one.
That's good.
Now, when I draw one diagonal, when you draw one diagonal, what it does is it creates two congruent triangles. When I draw just one diagonal, I end up with two congruent triangles created by one diagonal. So two congruent triangles created by one diagonal. Two congruent triangles created by one diagonal. Now, how do I end up with two congruent triangles? That's the question. What makes them congruent? Well, what do we already know? What you should already know, again, is that this side is congruent to this side. We already know that this side is congruent to this side. And what do they both share? This triangle and this triangle, they both share this line. Because if I cover it up, that triangle has that orange line. If I cover up this one, that triangle has the orange line. So they both use that orange line. So, they both have this line. So, what does that tell me? That they have all three sides in common. These two are in common, these two are in common, and of course they share that one. So therefore my two triangles are exactly the same. So this triangle is congruent to this triangle. They are exactly the same. Because they share all three sides. Huh? Yeah, I put that because I didn't want to put a mark. Because they already have all the marks on the side. So I just put a little star inside there. So, if you get any kind of a question that asks you about congruent triangles, it's right here. So if they tell you that you have two congruent triangles, and they say, well, okay, this side is 7, so what's that side? You automatically know. They have to be exactly the same. These are not trick questions by any means. So I've got at least one more that I want to show you. And this deals with diagonals. Okay, So in this problem, I've got my two diagonals. So, what they're telling me in this one, as I've got my two diagonals, this top diagonal piece right here is 3x minus 4. This bottom piece of the diagonal is x plus 5. Now, of course, my job again is to find x. Now, how is this going to help me find x? What did I just tell you about diagonals? Those two pieces are equal because we said that the diagonals cut them into two congruent pieces. So this piece is equal to this piece. So again, all I've got to do is set these two pieces equal to each other. So say 3x minus 4 equals x plus 5. As long as, again, I know my rules, I should be able to set them equal to each other and solve. And I believe this one should be a decimal if you solve it correctly. So right now, you should be solving, not looking at me. I've already set it up for you. All you got to do is actually solve it, and you should get a decimal. Devontae, you got a decimal? Okay. So if you solve it correctly, you should get a decimal. Okay, and we'll go ahead and solve this real quick. So, again, I like my letters in the front. So I'm going to move this. Remember, that's a 1. So x's can only go with x's. So I'm going to subtract 1x from 3x. So 3 minus 1 is going to give me 2x minus 4 equals 5. So now I need to move the 4 back. They have to go in opposite directions. So if I'm subtracting 4, then I need to add 4. So now 2x is going to equal
Excuse
9.
the interruption. Will the seniors of TAP classes Day, Goosh, Lewis, and Holland please report to the library for pictures? Will the seniors with the TAP class of Day, Goosh, Lewis, Holland, and Ashley report to the TAP library for pictures?
So I should end up with a fraction 9 over 2. So when you divide 9 divided by 2, what do you get? You should get 4.5. So the key, know your set of rules. Know what is equal and all of those things, and you should be perfectly fine. So any questions, any problems, anything at this point? So everybody's good.